Well, I just wanted to give you a quick tutorial in case you missed anything in Lesson 8, Estimating Quantities. I'm just going to run through all the exercises and your homework. Feel free to copy. Make sure you show your work. So this says the Federal Reserve, that's like the U.S. National Bank. Peru has one as well. This says that the average household debt in January of 2013 had $7,122 in credit card debt. That's a lot. About how many times greater is the U.S. national debt, which is about $16 trillion. And that's in 2013. Now it's upwards of 22 trillion, 21.5 trillion. Rewrite each number to the nearest power of 10 that exceeds it. So this number, 7,122, I'm going to rewrite it as a power of 10 that exceeds it. Well, I need 10,000 would exceed that. So 10,000 is 10 to the fourth power. And then I'm going to write this big number, 16, blah, 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 as a power of 10. I need to make it 100 trillion, not 16 or not 10, because it has to exceed it. It has to be bigger. So to make it 100 trillion, I need 2 zeros here, then 3, 3, 3, 3. So that's 12 plus 2, which is 14 zeros. So that's about 16 trillion, or that's going to be 100 trillion, and that is 10,000. Now I want to know how many times greater the national debt is than the personal debt. Well, to figure out how many times greater something is, all you have to do is take the numbers you're comparing, and I'm taking the national debt, which is my larger number, and comparing it with the household debt, which is 10 to the fourth, and I'm dividing. And this is why we did all those rules of exponents, one of the many reasons. But this helps us now because I have the same base division. This is going to be 10 to the 14 minus 4, or 10 to the 10th power. So that means the average, or the U.S. debt is 10 to the 10th power times greater than the household debt. Okay? So this division is really important. All right, let's look at the next one. This says there are about 3 million students attending K-12 in New York. Express the number of students as a single-digit integer. Remember, integers are whole numbers. Times a power of 10. So my single digit is going to be 3 times a power of 10. Well, what power of 10 times 3 equals 3 million? That would be to the 6th power. I got 3 zeros, 3 more zeros, that's 6 zeros. So this is equal to 3 million. All right? 3 million. I still have trouble writing, even with a pen. The next part of this question is, it says the average number of students attending a middle school in New York is 8 times 10 to the second power. How many times greater, again, that's going to tell me division, is the overall number of K-12 students compared to the average number of middle school students? Well, I'm going to take the total number of students, 3 million. I'm going to divide it by the number of middle schoolers, and if I look at this, it's going to give me 10 to the fourth power. I subtract. 6 minus 2 is 4. I can take this number and I can divide 3 divided by 8, and it would give me 0.375 times 10 to the fourth. And if I did that, it would end up being 3. I move my decimal 4 places. 1, 2, 3, 4. About 3,750 times greater. Okay, but if it just says about how many, you can say about 1,000 times greater, 10 to the fourth power. This is more specific. Here, 3,750 is more specific because I took into account this part. I divided that part also. All right, let's keep going and see what the next ones, where the next one lead us. And now I have a conservative estimate of the number of stars in the universe. Stars in the universe, I love looking up at stars, is 6 times 10 to the 22nd power. That's a lot, that's a huge number. The average human can see about 3,000 stars. I'm going to write that in scientific notation. 10 to the 3rd power. About how many times more stars are there in the universe compared to the stars in the human eye? I'm going to divide. 6 divided by 3 is 2. 6 divided by 3 is 2. 10 to the 22nd divided by 10 to the 3rd is 10 to the 19th. So there's about this many more stars in the sky, or more stars in the universe than we can see on an average night. That's a lot of more stars. Exercise 4. The estimated world population is 7 times 10 to the 9th. Of the total, 682 million of those people were left-handed. Approximately what percentage of the world population is left-handed? Well, percentage is always out of 100, part to the whole. So I'm going to take this number, 682 million, and it says approximately, so I'm going to round that to 700 million, which would equal 7 times 10 to the 8th power. Because 10 to the 6th power is 7 million, and I need 700 million. I have to add those two zeros here. And then I have 7 times 10 to the 9th power here, which is the world population. That's 7 trillion. We're now at about 7.5 trillion. So now, in order to figure out what percentage, I divide 7 by 7, I get 1. I divide 10 to the 8th power divided by 10 to the 9th power. I subtract the exponents, which gives me 10 to the negative 1. This ends up being 0.1, right? 1/10, because that's 1 over 10. And if I change that to percent, I move the decimal 2 places, and I get 10% of the world population is left-handed. Not a huge percentage at all. Very small percentage. All right, keep going. Number 5. The average person takes 30,000 breaths per day. That's a lot. 30,000 can be expressed as 3 times 10 to the 4th power. That's a single digit. 3. Power of 10 is there. If the average American lives about 80 years, hopefully I live a little bit longer, but the way I sound, maybe not, I get 3 times 10 to the 4th, which is 1 day, times 3 times 10 to the 4th, which is the 30,000 days. Well, here, if I'm multiplying these together, I can multiply my 3 and my 3 together. 3 times 3 is 9. I multiply my powers of 10. Remember, same base in multiplication, I add the exponents. That's how many breaths I take. Breaths in a lifetime. That's a lot of breaths. All right, that is the stuff that we were supposed to do in class. Most of us got through all of it, but your class may not have done all of them. So there you go. And now for the homework. Again, you don't have to listen to this, but it's here for you if you'd like. It's really riveting. Riveting, good Friday night fun for you here. Problem set. The Atlantic Ocean contains this many gallons of water. In the U.S., they use gallons, not liters. Lake Ontario has about that many gallons. 8 billion gallons. How many Lake Ontarios would it take to fill the Atlantic Ocean? So I'm going to do this. 2 times 10 to the 6th divided by 8 times 10 to the 369. That doesn't make sense. That's 16, not 6. I was like, that doesn't make sense. And then I divide. 2 divided by 8 is 1/4 times 10 to the 7th power, which equals 0.25 times 10 to the 7th. And that will work for now. We'll learn how to move that decimal place later. The U.S. National Forest covers approximately 300,000 square miles. Conservationists want the total square footage force to be 300,000 squared, which is 300,000 times 300,000. When Ivana used her phone to do the calculation, her screen shows this. And if you do this on a computer or a calculator, you'll probably see that. What does the answer on her screen mean? Well, she did 300,000, which is this, 10 to the 5th power squared, right? Well, that would be 3 squared times 10 to the 10th power. Because I distribute, all right, I share that 2 out there, I multiply everything inside, and I get 9 times 10 to the 10th power. Well, if this is what that means, then that E just must like bring it to scientific notation somehow. 9 to the 10 times 10 to the 10th power. That's what it means. Now it says, given that the U.S. has approximately 4 million square miles of land, is this reasonable? Well, this number is much, much greater than 4 million. Way bigger. Because 4 billion is 4 times 10 to the 6th. So it is not reasonable because there's not even that much land for conservationists. So it's not reasonable. Last two. The average American is responsible for about 20,000 kilos of carbon emission. That's why I can't breathe. Express this number as a single-digit integer times the power of 10. Well, 2 is my lead digit. Times 10, 1, 2, 3, 4 to the 4th power. It's a lot of carbon. The United Kingdom is responsible for about 1 times 10 to the 4th of carbon emission pollution each year. Which country is responsible for greater carbon emission pollution each year and by how much? So the U.S. is, because if you see it written like that compared to that, the U.S. is, right? And I need to compare this number with that number. So I have 2 times 10 to the 4th, 1 times 10 to the 4th equals 2 times 10 to the 0. Well, 10 to the 0 is just 1. Anything to the 0 power is 1. So it is 2 times more pollutant in the U.S. I wonder what the populations are. If we have twice as, sorry, that should be a pollutant. I wonder if we have twice as many people. That might explain why we have twice as many pollutants, but I don't think so. 2 times more pollutant. And there you go. That's how we compare numbers written in powers of 10. And this is the intro to scientific notation. Next lesson, we will talk about how to add and subtract in scientific notation. I hope this helped if you were absent, or if you just needed a review because I didn't do a good job in class or you weren't paying attention, whatever it might be. I'll see you guys next class. Thanks.